Okay, I wanted to do a lecture to explain production possibilities, frontiers, opportunity costs, and the comparative advantage model. Um, okay, we begin with some terminology that we introduce in economics. One term is scarcity. Scarcity means that there is limited resources. So on Earth, we have limited resources. Resources refers to things that you use to create other things. Okay, so for example, land is a resource, labor, that's the workers, machines, factories, right? Minerals, whatever is something that you can use in order to produce other things. These are resources. And the point is that we have limited resources. The fact that we have limited resources is termed scarcity. Okay? In other words, one way to think about scarcity is that we have a limited pie. And so we have to decide how to allocate the resources in such a way to minimize any waste of resources. Okay? When we talk about poverty, it just means you have a small slice of the pie, but it doesn't deny the fact that there's a pie. So whether you're rich or poor doesn't affect the fact that there is scarcity. You cannot deny that there is scarcity. Because we have to make choices of where to allocate our resources, we recognize that whenever we make a choice to put a resource towards one use, we're giving up another thing that we could be doing. And so that's where the concept of opportunity cost comes in. So opportunity cost refers to the next best alternative you could be facing. The next best use of whatever it is, the resource, or it could be for other things, of resource, okay? Next, I want to introduce the production possibilities frontier model. Okay, and the production possibility frontier model is a model that simplifies the world, okay, to try to learn some insight. So the simplification we're going to impose is that the world has only two goods, one resource, okay? Let's say the two goods are coconuts and fish. Okay, so let's say you have 10 people. So the resource is labor. So let's say you got 10 people on an island, okay? And so the 10 people have to figure out how to make the best use of their time on the island, okay? If all 10 people spend their time collecting coconuts, the most coconuts they can collect is 20. If all 10 people go and try to get fish, the most they could get is, let's say, 30 fish. And if we were to connect these 2 points, okay, this would be, so this is if all 10 people are collecting coconuts, this is if all 10 people are fishing, and any other point on this line is where some people are fishing and some people are collecting coconuts, okay? If all 10 people are working in one of the 2 possible things they could be doing, then they would be somewhere along this line. This line is referred to as the production possibilities frontier, or PPF for short, okay? Because it basically tells me nobody's wasting their time, they're all working, so this is the outcome, this is the any point on this line tells me this is the combination of fish and coconuts you could achieve if you have 10 workers. And for example, this would be the combination of coconuts and fish if you have 10 workers and you allocated them like this. This would be the combination of coconuts and fish that you would get if you allocated the workers this way, right? But the point is that if all 10 workers are working, you're going to produce somewhere along your production possibilities frontier. Could you reach this point? No, this is unattainable given your current level of resources and your current technology for fishing and collecting coconuts. Could you be over here? Yes. Over here means not everybody is working to their capacity. Okay? Let's actually think about this line a little bit more carefully. Okay. Okay. So, if you are on this line, okay, let's think about the opportunity costs that you face. So you could put the 10 people to collect coconuts, and you would get 20 coconuts. Alternatively, you could put all 10 people to go fishing. You get 30 fish. If you set these two equal to each other, okay, then we can divide both sides by 20, okay, and we would then say one coconut. When you collect that coconut, what are you giving up? 3/2 fish. Okay, the opportunity cost of one coconut is 3/2 fish, or 1.5 fish. Okay, alternatively, I could start out. By the way, we could say 20 coconuts have an opportunity cost of 30 fish. 30 fish have an opportunity cost of 20 coconut. We're just trying to simplify. If you divide both sides by 30, you would say one fish has an opportunity cost of 2/3. Oh, it's not letting me go below it. 2/3 fish. Okay, so this is a statement of opportunity cost. Okay, so if you're on the line, if let's say you have 6 fish and 15 coconuts, right? So you're at point A. If you would like to have more fish, the only way you can get more fish is by giving up some coconuts, right? So going from point A to point B involves having more fish, and in order to have the more fish, you have to give up some coconuts, right? Because if you're on the frontier, you're already maximizing the use of your resources. The only way to get more of one output is if you give up the other output, okay? But if you're inside the frontier, okay, probably because some of the workers aren't working, then if you have 6 fish, you could actually get more fish without giving up any coconut at all, just by getting your workers to work to go to the fishing sector. Or alternatively, you could have more coconut without giving up more fish. So if you're inside the frontier, you could have more than one output without giving up of the other output. But if you're on the frontier, there is an opportunity cost, and in order to have more of one output, you have to give up some of the other outputs. Okay? Another thing I want to talk about with respect to the production possibilities frontier is that the way I'm drawing it, fish and coconuts, I'm drawing it as a straight line. The straight line saying that whether I'm producing 20 coconuts or 0 coconuts or 10 coconuts, right? No matter how many coconuts I'm producing, okay, if I want to get one more coconut, I'm going to have to give up 1.5 fish. So the opportunity cost, which is really the slope of the production possibilities frontier, is constant along the frontier, okay? In order for that to be the case, it has to be the case that the resources are their productivity at fishing and their productivity at coconut gathering is the same regardless of how many coconuts they've picked, regardless of how many fish they have captured, they have caught. Okay, right? Because we're saying if if the worker has 20 coconut, or if the worker has 5 coconuts, to get one more coconut, he's giving up 1.5 fish. If the worker has 19 coconuts, to get one more coconut, he has to give up 1.5 fish. If the worker has 1 fish, to get more fish, he has to give up 2/3 of a coconut. If he has 29 fish, in order to get more fish, he has to give up 2/3 of a coconut. So this should be coconut. Okay. In a way, that's kind of robot-like, right? You can imagine there's like a robot. You put a switch on the robot, get fish, okay, or get coconuts, and the ratio of productivity in coconuts versus productivity in fish. If you have a robot, the robot doesn't care how much fish he's already caught, doesn't care how many coconuts he's already picked. The productivity is the same. But with people, we would imagine. I'm gonna have to clear the screen. A second. We would imagine that when it comes to people, okay, let's say that you have no fish at all, we would imagine that the first effort at fishing would be very productive. So if you even send one worker over to fishing, you would catch a lot of fish without giving up much coconut. But as the worker fishes more and more, it becomes harder and harder to get more fish, so that when you've already caught this much fish, to get more fish is hard, and so you're going to have to get a lot more workers fishing to get more fish. Okay, so that you see the slope is getting steeper and steeper. Or if you want to see it from this point of view, if nobody's picking coconuts, the first worker you send to collect coconuts is very, very productive. Look how much coconuts he gets, and you only give up a little bit of fish. By the time you've collected a whole bunch of coconuts, there's very little coconuts left to pick. So, so at that point, you'd have to give up a lot of fish because you have to send a lot more workers, and you'll only get a little bit of coconut, right? So the idea that the production possibilities frontier is typically curved in such a way, this is what we refer to as increasing opportunity cost. Okay, so if we draw the production possibility frontier as a straight line, that is constant opportunity cost. If we draw it as a curved line this way, that is increasing opportunity cost. The slope of the production possibility frontier is the opportunity cost. When it's curved this way, the slope is becoming steeper and steeper, meaning that the opportunity cost is becoming higher and higher. Okay. Another thing that I want to note with respect to production possibilities frontiers is getting back to a straight line production possibility frontier. So from here on, we're just going to stick with a straight line just because it's simpler to deal with, okay, even though in real life probably the production possibilities frontier is curved. But let's say this is the production possibility frontier. If I get more workers and they are just as productive at fishing as at coconut picking, okay, then you imagine that the whole production possibilities frontier line shifts outward. Okay, this is where more workers, or if you have some kind of technology. Okay, let's stick to more workers. What if there's some kind of a flu epidemic and half the workers die? So then the frontier would shift inward. Okay, but notice that it's a parallel shift because it's not affecting coconuts any differently than fishing. Both sectors are affected similarly. Okay, but you could also have situations where, suppose I tell you that this is the original production possibilities frontier. Suppose I tell you that Somebody invented a better fishing rod that allows people to catch more fish than they used to. So in that case, that technology doesn't affect coconut production, right? So then the maximum amount of coconut you can get if you send all your workers to collect coconuts is the same, but now you can catch more fish than before. So the whole production possibilities frontier shifts outward in favor of fishing. You can also think of in a situation where perhaps coconut picking, there's a technology that helps it, right? So that would move out. Okay, so this would be a biased shift, as opposed to the first one is a parallel shift. Okay? All right, now, normally, if a country is not trading with anybody, okay, this is the production possibilities, that's your potential, so to speak, okay? Let's say you choose to produce at this point. So you choose to allocate your workers such that you have 10 coconuts and 10 fish, okay? So if the production is 10 coconuts and 10 fish, how much coconuts and fish can you consume? Can you buy? Can you eat? Only 10 and 10, right? Because if you're not trading with anybody, your production possibilities are also your consumption possibilities, right? This is consumption. You can only consume what you actually produce. Okay, so now we're going to talk about the trading model. Okay, so the trading model says, let's say you have two countries. Okay, in this country, they can catch 20 coconuts or 10 fish. And in the other country, okay, in the other country, why is this not? Okay, in the other country, they can get 30 coconuts or 20 fish. And both countries have the same number of workers, okay? 10 workers each, okay? So what can we say about these two countries? So this is country, let's call it Islandia. And this one is called Urbania. Two countries, okay? All right, well, let's talk about the opportunity costs in each country. In Urbania, the opportunity costs are 20C equals to 10F. If we divide both sides by 10, then we have one fish has an opportunity cost of 2 coconuts. Alternatively, one coconut has an opportunity cost of 1/2 of a fish, which we could compute from this, or we can go back here and divide both sides by 20. Okay, so that's what the opportunity costs look like in Urbania. If we go to Islandia, you have 30 coconuts equals to 20 fish. Okay, that means that divide both sides by 30. You have one coconut equals to 2/3 of a fish, or alternatively, it would be one fish costs 1.5 coconuts. Okay? All right, so these two countries are not trading with each other. Each one is doing its own thing. Okay? But you can see that there is incentive for trading. Why? Because one coconut in Islandia costs 2/3 of a fish, right? For every coconut you collect, you're giving up 2/3 of a fish. But in Urbania, every coconut, you're giving up a half of a fish, which is less, right? So coconuts are cheaper in Urbania. What about fish? In Islandia, one fish costs you 1.5 coconuts, but in Urbania, one fish costs you 2 coconuts. So you see that fish are cheaper here in Islandia, okay? While in Urbania, coconuts are cheaper. Okay, the statement that coconuts are cheaper in Urbania, another way to say it, so coconuts are cheaper here. Another way to say that is Urbania has a comparative advantage in coconuts. Okay? And if we were to make a similar statement for Islandia, we would say fish are cheaper here. So that would be right past that line. Cheaper here. Okay? Or that's the same as saying that Islandia has a comparative advantage in fish production. Okay? Each country can only have a comparative advantage in one of the two goods. Okay? You cannot have a comparative advantage in both goods because the way we're computing comparative advantage is using opportunity cost, and opportunity cost is defined in terms of the other good. So if you do one good cheaper, therefore the other good is more expensive necessarily. Okay? Alternatively, there is a concept of absolute advantage. Absolute advantage doesn't look at opportunity cost. It looks at actual cost of production. So for the same 10 workers, if in Islandia they produce 30, those workers are so productive they can produce 30 coconuts, but in Urbania they can only produce 20. That means Islandia has an absolute advantage in coconuts because the workers can produce more coconuts per worker than in Urbania. Also, the workers in Islandia can produce more fish than in Urbania. So Islandia has an absolute advantage in coconuts and in fish. Urbania has an absolute disadvantage in coconuts and in fish. But it's not absolute advantage that matters, it's comparative advantage that matters. And comparative advantage determines which way the trade works. Okay, so now let's keep going with the trading idea. Okay, what would be the price at which they exchange? If these two countries were to trade with each other, what would be the price at which they exchange goods with each other? Well, we said Urbania produces coconuts cheaper than Islandia, so Urbania is going to specialize in producing only coconuts, and they're going to sell some of their coconuts to Islandia in exchange for fish. Okay? So, if they were to sell all of their coconuts to Islandia, what would be the price they would be willing to accept? So the price of coconuts, okay, has to be no less than half a fish, right? Because in Urbania, it costs them half a fish for each coconut, so they're not going to be willing to accept the price of less than half a fish. And the price can go as high as one coconut, 2/3 fish. Okay, because Islandia is not going to be willing to pay more than 2/3 fish. So the price of coconuts has to be in between these two extremes. Okay, the price of fish. Who's selling fish? Islandia is selling fish. The cost of fish in Islandia is 1.5 coconuts, so the price can't go lower than 1.5, and it can go as high as 2 coconuts, which is what Urbania highest that Albania would be willing to pay. Okay? Now, where does the price end up? That's a function of bargaining power. Each side is going to bargain. Islandia is going to try to push the price of fish to as high as 2 coconuts. Albania is going to try to push the price of fish down to 1.5 coconuts. Similarly, right, Albania is going to push the price of coconuts to 2/3 fish. Islandia is going to push back to 1/2 fish. So depending who's better at bargaining, the price will move in their direction. Okay? Let's say, okay, so suppose I say that, the price ends up being, so I'm just going to tell you what the price turns out to be. So let's assume that the price turns out to be in between. Okay, so let's say the international price, which we refer to as the terms of trade. Terms of trade is the actual price that settles in the international market. So let's say the price of fish is equal to 1.75 coconuts. Okay, this is the actual price. By the way, if I tell you the price of fish is 1.75 coconuts, if I divide both sides by 1.75, I would get that 1 coconut equals to 1 divided by 1.75 fish. Let's see. So 1 divided by 1.75 is 0.57, right? So that implies that the price of coconuts equals to 0.57 fish. Okay, this is the international price, okay? All right, so Albania would produce only what they have a comparative advantage in, which is coconut. They would produce 20 coconuts. If they sell all the coconuts to Islandia in exchange for fish, how much fish could they get? Let's see. Okay. Okay. So if they produce 20 coconuts, each coconut is selling for 0.57 fish. Okay. So 20 times 0.57 fish, 20 times 0.57 fish is 11.4 fish. Okay, so if they would like to get 20 coconuts and eat the 20 coconuts, this is the point they would choose on their consumption frontier. If they want to sell all the coconuts for fish, they could consume 11.4 fish. And if they want to sell some coconuts in exchange for fish, they might end up anywhere on this line, any combination. Okay, but the point is that this line is what we call the consumption possibilities frontier. That's the frontier along which they can consume. These are the bundles they can choose to consume if they trade. If they didn't trade, they would be stuck on their production possibilities frontier. They can't consume beyond that. But with trade, they're able to consume a larger amount of coconuts and fish than they used to without trade. Similarly, for Islandia, they would produce only fish, so they would produce 20 fish. If they're producing 20 fish, each fish sells for 1.75 coconuts. Okay, so 1.75 times 20 is 35 coconuts. So in exchange, they would get 35 coconuts. So the consumption frontier is this, which again, you see, the consumption possibilities frontier when you trade gives you access to more bundles than you had access to if you didn't trade with anybody, because then you were stuck on your production possibilities frontier. Okay? So that's basically the concept of comparative advantage and absolute advantage. Okay? Trade is based, or the direction of trade is based on comparative advantage. Trade gives you access to more consumption than you would be able to afford if you did not trade. Okay? As long as two countries have different opportunity costs, there is room for trading. Okay? And trade will make both parties better off. The only time that trading will not happen is if both countries have the same opportunity costs. So if, for example, 20 to 10, 30 to wait a minute, 20 to 10, 40 to 20, right? 2 to 1, 2 to 1. If both of them have the same ratios, then there is no reason to trade. Okay? I hope you found this helpful.